Welcome to today's video on approximation and errors, detailed notes. We will start by defining the one approximation. It involves expressing a number or measurement in a simplified form that is close to its actual value. This process is often used when exact values are not required or the exact values are too cumbersome to work with. Common methods of approximation. 1. Rounding off to a specific number of decimal places or significant figures. Rules for rounding off. If the next digit is 5 or greater, round up. If the next digit is less than 5, round down. Common methods of approximation, rounding over examples. Round 3.846 to 2 decimal places. And therefore, 3.846 implies that it is 3.85 to 2 decimal places. So here we round up because it is greater than 5. Round 0.004567 to 2 significant figures. So it will be 0.046 because after the 5 we have a 6, so we round up. Truncation. Cutting off digits beyond a certain point without rounding up. For example, truncate 3.846 to 2 decimal places. So it's like chopping. So you have just, you omit 6 and you write it as 3.84. You see here, we have not rounded up. We have just chopped 6. Truncation. We have truncated. Types of errors. Errors arise when approximations are made. They measure the difference between an exact value and an approximated value. So, types of errors, we have the first one type is absolute error. The absolute difference between the true value and the approximated value. And absolute error is always true value minus approximated value. And you can see the symbol for absolute. Absolute means you don't have any sign. You don't have negative or positive sign. You omit the signs. If the exact value is 52.4 and the approximated value is 52.0, the absolute error is 52.4 minus 52.0, which is 0.4. The next type of error is known as the relative error. The ratio of the absolute error to the true value. Relative error equals absolute error over true value. Example, using the values t 52.4 and a 52.0, relative error will be 0.4, which was the absolute value we had seen earlier, over the true value 52.4, and you get approximately 0.00763. Percentage error. Express the relative error as a percentage. So percentage error equals relative error times 100. Example, continuing with the relative error 0.00763, percentage error will be 0.0763 times 100, which is roughly 0.763%. Limits of accuracy. When measurements are rounded off, they are approximated to a range of values known as their limits of accuracy. Upper and lower bounds. For a number rounded to a certain unit, lower bound, rounded value minus unit over 2. Upper bound, rounded value plus unit over 2. Upper and lower bounds. Examples. A length rounded to 1 decimal place is 6.2 centimeters. So the unit is 0.1. All right. It's approximating to roughly 0.1. Lower board 6.2 minus 0.1 over 2, which gives you 6.15, and upper board 6.2 plus 0.1 over 2, which is 6.25. A weight rounded to the nearest kilogram as 75 kg. Here, the unit value is 1, and lower bound 75 minus a half, 1 over 2, which is 74.5, and upper bound is 75 plus a half, which is 75.5. Error propagation in calculations. Errors can propagate in mathematical operations. Understanding how errors are carried through calculations is essential for precision. Addition and subtraction. The absolute error of the result is the sum of the absolute errors of the operands. Operands are the numbers we are working on. For example, approximate A equals 6.5 plus or minus 0.1 and B equals 3.2 plus or minus 0.1. Sum A plus B will be 6.5 plus 3.2, which is 9.7. Absolute error will be 0.1 plus 0.1, which is 0.2. Final answer will be 9.7 plus or minus 0.2. Notice the way I split the numbers 6.5 and 3.2, and then I take the errors. Plus is the upper bound, negative is the lower bound. Multiplication and division. The relative error of the result is the sum of the relative errors of the operands. Example, approximate 4.0 plus or minus 0.1 and B 2.0 plus or minus 0.1. Relative error for A is 0.1 over 4, which is 0.025, and the relative error for B is 0 over 1 over 2 equals 0.05. Total relative error will be 0.025 plus 0.05, which is 0.075. Approximation of A times B is 4.0 times 2.0 is 8.0. Absolute error will be 8.0 times 0.075, which is 0.6. Final answer, 8.0 plus or minus 0.6. Practical applications. Approximation and error analysis are critical in fields such as engineering, medicine, science, and finance. Additional examples. Round 3.56789 to three significant figures, and you get the answer as 3.57. Error in division. A calculated speed is 5.0 kilometers per hour, plus or minus 0.5 kilometers per hour, and the time taken is 2 hours, plus or minus 0.01 hours. Find the distance. Distance equals speed times time. 50 times 2 is 100. Relative error in speed is 0.5 over 50, which is 0.01. Relative error in time is 0.01 over 2, which is 0.005. Total relative error is 0.1 plus 0.005 is equal to 0.015. Absolute error. Absolute error, 100 times 0.015 equals 1.5. Therefore, the final distance is 100.0 plus or minus 1.5. Appreciate assistant by ChatGPT, OpenAI. Goodbye and see you in my next video on approximations.